The other very popular distribution is called uniform distribution. As the name suggests, uniform distribution has some uniformity in it. I'll show you. I'll show you exactly what it is. Before we go ahead and understand uniform distribution, there are two types of uniform distribution. There is a discrete uniform distribution and there is a continuous uniform distribution. And discrete uniform distribution is nothing but, earlier in the chapter we learned about discrete and continuous random variables, right? And continuous random variables. So if a random variable is discrete and if it follows uniform distribution, it's called discrete uniform distribution. If a random variable is continuous and if it follows uniform distribution, it's called a continuous uniform distribution. Now let's go to Wikipedia and understand discrete uniform distribution and continuous uniform distribution in more detail. Okay. Instead of me drawing, it's always good to follow Wikipedia, as drawings are much more clean. The data is readily available. So in a uniform distribution, it's called a probability mass function. I told you about probability density function, right? So probability density function and probability mass function are literally one and the same, except for a small difference. We write a probability density function for continuous random variables. We write a probability mass function for discrete random variables. But intuitively, they are one and the same. So what they measure, the height literally in the probability mass function or probability density function tells us what is the probability of finding that value. Okay, so it's no more called density, so it's called probability density function for continuous random variables and mass function for discrete random variables. Otherwise, there is no intuitive difference between a PDF and a PMF. This is called a PMF. So whenever I say a PMF, it's automatically understood that I'm talking about a discrete random variable. Whenever I say PDF, it's obvious that I'm talking about a continuous random variable. I've seen a lot of lectures and classes where people use these two terms interchangeably. People call everything PDF. That's okay, but it's good to make difference. It's good to clarify the difference sometimes. Okay, now let's understand what is a uniform distribution. So let's take an example. Okay, I think an example would surely help. One of the simplest examples of a uniform distribution is throwing a dice. A fair dice, of course, that's important. A dice has 6 sides. A dice is like this, right? A dice has 6 sides. Okay, and when you throw a dice, you can get 6 possible values: 1, 2, 3, 4, 5, and 6. Okay, and all of them are equiprobable. So the term there is equiprobable. Probable. What does it mean? The chance of getting 1 is the same as chance of getting 2 as the chance of getting any other value here. Okay, so the probability of getting any value, the probability of getting any of these values is 1 by 6, which means the probable, and there are 6 outcomes here. That's important to notice. When you throw a dice, there are 6 possible outcomes, and all the 6 outcomes are equiprobable, which means all of them have the same probability. That's what exactly a uniform distribution is all about. Imagine if I have 5 outcomes. Okay, imagine I have 5 outcomes between A and B. And if all of these 5 outcomes, so let's say n equals to 5. So again, just like Gaussian distribution, just like your Gaussian distribution has parameters mu and sigma, right? What are the parameters of your uniform distribution? There are 2 parameters. There is A and B. There are A and B, which are parameters of your uniform distribution. And n is nothing but, and A and B are integers. Look at these. A and B are integers. Okay, and B is always greater than A. Most importantly, n is nothing but B minus A plus 1. Okay, let n be B minus A plus 1. In our coin toss example, we can write, since we have 6 values here, we can take our A to be 1, our B to be 6. Okay, because there are 6 values and I've given them 6 values, 1, 2, 3, 4, 5, 6 in our coin toss example. Okay, and your n is B minus A, which is 5 plus 1, which is 6. So n basically tells us the number of outcomes. The number of outcomes we have. That's what n tells us. And A and B tells us what the numerical values we're giving to the output. Imagine, let's take a simple example here. Imagine if n was 5, okay? And so let's assume this is 2, 3, 4, 5, 6. This is not a coin toss example here, by the way. Some other example, okay? So you have a uniform distribution with values 2, 6. These are the two parameters, right? This is A and this is B. Again, just to quickly recap, these are called the parameters of the distribution. Just the way a Gaussian distribution has mu and sigma as the parameters. And what do you mean by parameters? If you know the parameters, you know almost all the information that you need to know about the distribution. Similarly here, if somebody gives you A and B, you know everything about the distribution. In a uniform distribution, all of the values are equiprobable. All of the values are equiprobable. Okay, what does it mean? It means the probability of finding any of these values equal to 1 by n, if there are n such values, right? Which is exactly what we saw in coin toss also, if you recall. In coin toss, we had 6 outcomes, 1, 2, 3, 4, 5, 6, right? Our A was 1, our B was 6, our N was 6, of course, right? And what is the probability of getting any single value in this? It is 1 by n, which is equal to 1 by 6. Okay, so basically a uniform distribution says that the probability of getting any value is uniform and it's exactly the same value. Okay, now you might say this is your probability mass function, right? And remember, you can't draw a line like this here because there is no value for, suppose if this was 2, 3, 4, 5, 6. There is no interpretation for the value 2.5. You can never get 2.5. In coin toss, can you get 2.5? No, you can never get 2.5 in coin toss, right? So there is no interpretation for these values. So whenever you write a PMF, it's going to be just dots like this. The probability of getting this value is 1 by n. Probability of getting this value is same, so on and so forth. And there is no probability of getting any other value in between. So that's why it's a discrete random variable, because it can only take these discrete values. It can take this value, this value, this value, this value, or this value. It can't take values in between. Okay. Now, of course, we can always compute the cumulative distribution function. You just have to continuously sum it up, right? So the distribution function actually looks like this. So what is the probability of a value less than equal to, of less than a? It is 0, right? What is the probability of a value which is less than equal to a? It's exactly equal to a. This is called a non-smooth function, because typically you'll see a smooth function. When we see continuous distribution, you'll understand this much better. Okay. Now let's go and understand some basic properties of uniform distribution. It has two parameters, a and b, and n is nothing but b minus a plus 1. N is basically number of outcomes, and the probability of each outcome is 1 by n, right? The mean of a uniform random variable is a plus b by 2. You can derive this. This is very, very straightforward. And the median also is a plus b by 2. Right? You can also compute the variance. I mean, the computation is variance computation is non-trivial. Mean and median is trivial. Okay. Suppose, let's take a dice example, right? We have 1, 2, 3, 4, 5, and 6. Okay. We have 6 outcomes, and each of this outcome has a chance of getting 1 by 6, 1 by 6, 1 by 6. These are the probabilities, right? Now, if you do a simple simulation in computer program, you can easily verify that it will be a plus b by 2. Okay, so the mean value will be 7 by 2, which is 3.5. The median also will be 3.5, because all of them are equiprobable, right? All of them, the chance of getting any value is the same. So the mean and median for a discrete random variable, which is uniformly distributed, is a plus b by 2. We need not worry too much about, again, the other important thing here is the skewness is 0. This distribution is not at all skewed. This distribution is not at all skewed. Okay, because if you look at it diagrammatically, right, it just n dots here. If I have n unique values that my uniform distribution can take. Now let's jump in and see how a continuous uniform distribution looks like, because that makes much more simple explanation for us. Okay, so imagine if I have again, the parameters are a and b, just like the previous case, and a uniform random variable, which is, again, the parameters are a and b. Here, remember, it's written probability density function. That automatically means that this is a continuous random variable. It automatically means that it's a continuous random variable. Now comes the interesting part. So if I have two values, this is called the minimum and this is called the maximum value. Okay. And all of the values in this, so the PDF of a uniform distribution for a continuous random variable is literally a line like this. Because the probability of getting any value here is the same. And what will such a probability value be? It will be 1 by b minus a. Because remember, the area under the probability curve, probability density function should be equal to 1, right? So this height is 1 by b minus a. So this is the probability density function of a uniform distribution. Now what about the probability density function, the cumulative distribution function of this? So it will be like a straight line like this, okay? Because as you go from b to a, you're slowly increasing. Of course, the maximum value will be 1, the minimum value will be 0, but it's just a line, a straight line like this. Okay. Again, Wikipedia summarizes all of this information brilliantly for you. So what it says is the parameters are a and b. Of course, a should be strictly less than b, and a should be greater than minus infinity, and b should be less than minus infinity, right? And what is the PDF? It says it is 1 by b minus a if x belongs to a comma b interval. Everywhere outside of that, it's 0. You can also compute the mean and median, which is a plus b by 2 and a plus b by 2, just like our discrete uniform distribution. Okay, so all these, so there are lots of distributions in nature. There is very interesting application of uniform distribution that we will see in the next video. Okay, this is a broad overview of what a uniform distribution is, what a discrete uniform distribution, what a continuous uniform distribution are. But this much is fairly sufficient for us to tackle the problems ahead of us.